Hello, everyone. I'm Frank, and welcome to Frank Puzzles. And just as a side thing, if you haven't subscribed to this channel and you enjoy the content, please subscribe because it lets me know that you support. It lets me see your support, and I appreciate it. Also, if you like the video, give it a thumbs up. And now on to today's easy level puzzle, which remember is we have a caveat with that because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of smart people there. And today's puzzle is called Galactic Echo by Wook. And here are the rules. Standard Sudoku rules apply. The digits 1 through 9 appear in every row, column, and box. Divide the grid into galaxies, orthogonally connected groups of cells that have a 180-degree rotational symmetry around their centers, marked with a brown dot. So these are the brown dots. All cells must be part of a galaxy's. All cells must be part of a galaxy, and no galaxies overlap. So therefore, every cell in this grid must be part of a galaxy, and you cannot have galaxies overlapping. So orthogonally connected means that basically cells share an edge. So a valid galaxy here would be something like this, right? Because they're all orthogonally connected. If you removed like these two cells, that wouldn't work because these are no longer orthogonally connected. So this is not a valid galaxy. And the thing is, it's rotation. So the galaxies are rotationally symmetric around their centers. So this works because if you rotate it 180 degrees, you get the same thing. So it's symmetric, right? So anytime you have like anything that's 2 away or 1 away from a dot, you know is specifically that the other side has to have the same, has to be in the same galaxy. Digits in galaxies do not repeat and sum to the number in its center if given, right? So in this example, this is actually not a valid example then, because digits don't repeat, and you can't have 6 digits that add up to 12. But say like this was length 4, then you know that this would be either 1, 2, 3, 6 or 1, 2, 4, 5 to be in this 12 galaxy, if it assuming this galaxy is correct, right? Because so this acts like a killer cage, if you know that term, that rule set. So digits in galaxies do not repeat and sum to the number in the center if given. So it's like killer galaxies, I guess. Digits separated by a white dot are consecutive and must belong to the same galaxy. So these are consecutive, which means if this was a 6, this would have to be a 5 or a 7, and they belong to the same galaxy. So you can't split up these into separate galaxies. All the white dots must connect cells that are in the same galaxy. The greater than points to the smaller digit of a domino, and this is here. So therefore, this would work. So, for example, if this was a 7 and this was a 2, but the reverse would not work, right? This could not be 2 and this is a 7, because 2 is not greater than 7. But this could be a 1, and that would work in that case. Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. First thing I can see, this. So first, actually, another thing. This is a galaxy by itself. Because it's rotationally symmetric around this center. It can't extend any more out this way, so therefore these 4 digits have to be in that galaxy. Okay, 40. 40 must be 7 digits at least. 7 digits, right? Because the minimum or the maximum you can have that adds up to with 6 digits. Actually, okay, well, first of all, this has to be an odd version galaxy, right? Actually, it could have been 6. No, it can't be 6. What am I thinking? It can't be 6. Because if it's 6, you can't have 6 because the maximum there would be 4, 5, 6, 7, 8, 9, which is 39. So therefore this has to be 7. And it can't go any way right, so therefore it can't go any way left. So it can only go up and down. And therefore there's only at maximum 7 here. So this has to be a 7 galaxy. So we know this is a galaxy. And we know these two add up to 5 because this has to be 40. So this is 45. This is 1, 2, 3, 4. This cannot be part of this galaxy. It couldn't anyways. So therefore, this has to be a galaxy in itself. This is the only way it can be because it can't be just two cells. And that's the only other possibility. So it's 4. These add up to 5. Therefore, these must add up to 17, of which you can only have then 8 and 9. So this is 8 and 9. This 12 cell could go here or could go here. This has to be a galaxy by itself. So we're going to make that orange. This must be part of something. It could be like this, but the problem... Okay, so this has to be a 2-cell galaxy because it's too small to be anything else. Right? 6... You can't have... You can only have 3 digits adding up to 6, but that wouldn't be rotationally symmetric. Right? So you can only have 2 here. So this is 1, 5, or 2, 4. This is a galaxy by itself, but we don't know if it could extend here. We don't know. So this is a gray area. We don't know what that is. Well, it can't be part of blue. I guess it could be part of this one. This one cannot extend any further this way. Therefore, this must be part of this galaxy. So we're going to make that, I don't know, green. So this has to be part of that galaxy. This must have at least more than 2. What part of galaxy is that? Can it be part of this? I guess so. This is 24. 2 digits can never be just 24. So it could, and it can't go this way because that's part of another galaxy. So it could go, it can't go here because that's part of another galaxy. Therefore, this must go down, which means these two are part of the same galaxy by the rules. Therefore, we know it's this. Therefore, these 6 digits must add up to 24. It cannot go any further this way. Therefore, these two, well, we don't know. Can't go any further this way. This one must be by itself because it cannot, this is not part of the galaxy. And therefore, it can't extend any of these 3 because these are different galaxies. Therefore, this must be its own galaxy, which means this one can only be part of this galaxy because this one is not longer allowed. This is it's not orthogonally connected here. Therefore, it must be green. Therefore, this is not part of yellow. So this is green, and this is not part of yellow. So we know this yellow has to be this size. This one can't go up, so therefore the galaxy must be this way. I'm going to make that orange. This one cannot extend this way, so it can't extend this way. It can't extend to any of these two, so therefore this must be a galaxy in itself. So this is blue. These two cannot extend this way. It could extend this way, but it can't extend this way, so therefore this is a galaxy into itself also. I'm going to make that pink. Where are these 2 cells? They have to belong to this galaxy because it can't extend any further. Therefore, we're going to make that there. This doesn't extend to this red one. It can't be this pink one. Therefore, it has to be part of this. So this is a galaxy. We're going to make that green. These two are part of the same galaxy, but not part of this one. It could be this one. That's fine. It could be... Okay, these two are part of the galaxy. And therefore, this is 4 digits already. This cannot be part of a galaxy. It can't extend any further here, so this is not part of that galaxy. So it can't be the part here. It could potentially be here, but then the problem is this would require, yes, 8 numbers in a galaxy, which to add up to 13, which is not allowed. So therefore, these are separate. These two then have to be part of this galaxy. So this, and we'll make that red. Let's see. These two are its own separate galaxy because it cannot extend further this way. These also are, well, we don't know about this. This is potentially possible, but probably not. This could go that way. Can it go that way? No. So where is this galaxy part of? Where is this? It can't be part of this, can't be part of this, can't be part of this. All these galaxies are already known. So this one could be part of this, but then that forces this to be 8 cells, right? 1, 2, 3, 4, 5, 6, 7, 8. And you cannot have the minimum 8 cells can add up to is 36, with each one being unique. And we know digits and galaxies are unique. So this cannot be part of the 27. The only one left is part of the 10. So this has to be 10. This can't be part of the green, can't be part of the pink. Can't be part of this question mark, so it has to be part of the 27. So this is a galaxy. Therefore, these two cannot be part of this galaxy because of these numbers. So therefore, these two must be part of this galaxy. And we know these two are a galaxy. So these are all the galaxies. Now we know this adds up to 10, and it's 4 unique digits, so it has to be 1 through 4, which means the rest of this has to be 5 through 9 in box 5. So this is 5, 6, 7, 8, and 9. This is 5, 6, 7, 8, 9, and this has to be 5, 7, 8, and 9, which means this correspondingly is 3, 4, 5, or 7. Let's see. This is 1, 2, 1, 6, 2, 5, or 3, 4. This must be us to have a 1, I believe, right? 1, 2, 3, 7 is the maximum you can have. Sorry, if you can't have a 1, it would be the minimum you would have is 2, 3, 4, and 5, which adds up to 14. So therefore, 14 is the minimum, but so it can't go any lower. So therefore, this must have a 1. And it must be with 2, 3, 4. It could be 2, 3, 7. Whoops. It could be 2, 3, 7. It could be 2, 4, 6. It could be 1. It could be 1, 3, 4, 5. We just know 1 is there. Let's see. This adds up to 27, so these 3 must add up to 18. We don't know anything else. This cannot be 3 or 9 or 4 or 8, so it must be 5 and 7, which means the rest of the column must be 1, 2, 3, 4, 6. This is 1, 2, 3, 4, 6. This is 1, 2, 3, 4, 6. 6 digits add up to 27. What can that be? Can you have a 9? Probably. Can you have 8 and 9? Yes, you can have 1, 2, 3, 4, 8, 9. Let's see. 1, 4. We don't know what that is. This is 12. This is consecutive. So it's either 6, 7, or 8 is here. We have 6 digits that add up to 24. What's the minimum here? This has to be 5, 6, and 7 as the minimum. So that's 18. These 3 digits must add up to 6. maximally, and that has to be therefore 1, 2, 3. So this is 1, 2, and 3. This has to be 5, 6, and 7. So all 3, 5, 6, and 7s are here. This can't be 5, 6, or 7. This can't be 5, 6, or 7. The 6 has to be here with 5 or 7, so this can't be 6. So this can't be 6. This cannot be 5, 6, or 7. It's 8 or 9. So we have an 8, 9, 8, 9 pair. This is 1, 2, 3. This has to be 1, 2, 3, 4. We have a 1, 2, 3, 4 quad in row 4. So the rest of the row cannot be 1, 2, 3, or 4. So this is 5, 6, or 7. This has to be 5, 6, 7, 8, or 9. These are 5, 6, 7, 8, or 9. This can't be 1, 2, or 3 here because we have a 1, 2, 3 triplet in box 6. So none of the other cells can be 1, 2, or 3. Cannot be 1, 2, or 3. Therefore, this has to be 4, and this is 6. So these can't be 4 or 6. This can't be 4 or 6. This can't be 6. Therefore, this is 5, 7, 8, and 9. This is 5, 7, 8, and 9. This can't be greater than, this has to be less than this, so this can't be 9. This can't be 5, therefore. So the 5 has to be one of these 3. The 4 is one of these 2, so this can't be 4. Therefore, we know the 4 has to be one of those 3. We have a 1, 2, 3, 1, 2, 3, 1, 2, 3 triplet in row 5. Therefore, the rest of the row cannot contain 1, 2, or 3. It can't be 6, so this is 4, 5, 7, 8. 4, 5, 7, 8, 9. This can't be 5, though. Let's see. This has to be a 1, 2, 1, 2 pair, because where else is the 1 or 2? Therefore, this is 4 digits that add up, 4 unique digits that add up to 25. If it's 1, it's 7, 8, and 9. If it's 2, it has to be 6, 8, and 9. So therefore, 4 and 5 are not allowed. And we know it's 1, 7, 8, and 9, or 1, 6, 8, 9. So none of the 8 and 9 can be in the rest of row 1, or column 1. So this is 1, 2, 3, 4, 5, 6, 7. This is 1, 2, 3, 4, 5, 6, 7. This has to add up to 18. And it cannot be 1, 8, 9 because that would eliminate all possibilities for this cell. So therefore, 1 has to be in one of the lower 6 in box 7. This can't be 1 again. So where is the 3 in column row 6? It can't be any of these. It has to be here. So this is 3, this is 9, which makes this 8. So the rest of this adds up to 19. Okay. So 3 cannot be here. So if this has to be then 1, 2, 7, it can't be 1, 2, 3, 7. It has to be 1, 2, 4, 6. That's the only possibility. So this has to be 1, 2, 4, 6. Obviously can't be 1 or 2 here. This is 4 or 6. The 5, where is the 5 in row 4? Can't be any of these. This one can't be because it can't be greater than any number else that would be here. This can't be 5. This can't be 5 because of the galaxies. So therefore, this must be the 5. This can't be 8 anymore. This can't be 8. This can't be 4 because we have 1, 2, 3, 4. So this must be 6, which means this cannot be 6. It cannot contain 1, 2, or 4 here. So this can't be 1 or 2. This can't be 4. What are 4 digits that add up to 25? If you don't have a 3 there, you don't have 1, 2, and 4, obviously. So if you don't have a 3, the minimum is 5, 6, 7, 8, which would be 26. So that's not possible. So the 3 has to be in this 25. So this can't be 3. This is 5, 6, and 7, which would be consecutive with 5, 6, 7, 8. This can't be 5, though. So we know 9 has to be one of these two. So this is 3 and 9, so that's 12. So the other two must add up to 25. If you have 6 and 7 here, sorry, The other two must add up to 13, which with 12 adds up to 25. If you try 6 and 7 here, this would have to be 5 and 8, which are not consecutive. Therefore, this has to be 6, 7, which makes this have to be 3, 5, and 8, 9. So 3 can't be here. 8 and 9 cannot be here. This can't be 4. So this is 5 with 7, 8, and 9. The 5 therefore can't be here because where is the 5? 5 has to in column 3. It has to be here. So this is set. This can't be 6 anymore. So if it's 6, 8, 9, that's 6. We don't know though. So this is 6 or 7, right? With 8 and 9. This is 6 or 7. There cannot be a 6 or 7 in the rest of the column. So this is 4 with 1 or 2. So we know the 4 is here. So this can never be 4 with anything. This can't be 1. You could have 5, 6, or 7. It could be 2, and it could be 3. But it cannot have 4 then. This adds up to 13. That doesn't really tell us much. 2 or 3. Because this is either 2, 1, 4 or 2, 3. If this is 2, 3, this would have to be a 1. So the rest of box 9 cannot contain a 1. In addition, can't contain 1, 8, or 9. Therefore, it's 2, 3, 4, 5, 6, 7. This is 2, 3, 4, 5, 6, 7. This is 8. So, okay, this is 6 and 7. Oh, this is 6 and 7, so this cannot be, this cannot contain a 6 or a 7. Therefore, this is 4, and this has to be one of 8 or 9. So this has to be 7 with 8 or 9. So then this has to be 1. So this is 1. This is 2. So this can't be 2, and it cannot be 5. So this has to be 2 and 4 here. We know this is we have an 8, 9, 8, 9 pair in row 7, so the rest of the row cannot be 8 or 9. So this is 5 or 7. This must add up to 18 because these 6 must add up to 27, and 45 minus 27 is 18. So can it do it without a 3? I don't think so, right? If it's the minimum there would be then 5, 6, and 8, which would add up to 19. So that's not possible. So this has to be 3. To add up to 18. This is 3. This has to be 1 with 6 or 7. It has to be... This can't be 7, so this is 6, which makes that 7, which makes this one 6. So, these add up to... How much? This is 7. This is 6. So this is 13. So therefore this must add up to 14, which means it's 5 and 9. So therefore this is 7. This is 8. This is 9. This can't be 8, so this must be the 8. This is 7 or 9, which makes this the 8. This can't be 7. This can't be 7. These three add up to 13, and with 7, therefore this must be 6 also. So this is 1, 2, 4, 5. So we have a 1, 2, 4, 5 quad in box 8, so the rest of the box cannot contain 1, 2, 4, 5. Therefore, it's 3, 6, 7, 8, and 9, and these can't be 8 or 9. We don't know about this. This cannot contain a 4 anymore. So the 4, because the 4 is here, this galaxy cannot contain a 4. Therefore, where is the 4 in box 9? It has to be one of these 3. We don't know which, though. This can't be 3. This can't be 3. So 6 has to be one of these 2, which means this can't be 6. This can't be 9 anymore. This can't be 9, which means 8 has to be one of these 2, because where is the 8 in row 6? It has to be on one of these 2 cells. So therefore, this can't be 8. This is a 5, 7, 8 triplet in box 6, so there cannot be a 5, 7, 8 in the rest of the boxes. Therefore, this is a 9, which makes that a 7 by Sudoku, and that a 9 by Sudoku. This can't be 7, so this is 5. This must be 7. 9 cannot be here, 9 cannot be here, 9 cannot be here, and 9 cannot be here, which means there has to be a 9 here. So the 4 other digits must add up to 27 minus 17, which would be 10, and therefore have to be 1, 2, 3, and 4. And it cannot contain 8, therefore this must be 8. So this can't be 8, so therefore this is the 8. And we have a 5, 7, 5, 7 pair in column 9, so the rest of the column cannot be 5 or 7. This can't be 8 anymore, so this can't be 8 here. This is 1, 2, 3, 4, and 9. This is 8. 9 is one of these 4, but 9 cannot be here. Seven cannot be here, 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 here in column 4. So where is the 7? It has to be one of those two. So this can't be 7. This can't be 7. We also knew, yeah, the 7 had to be here, so that couldn't be 7 anyways. So 3 or 6 is here. We're not sure which. 8 has to be here, which means 8 is one of those two. We don't know which, though. 7's here, 7's here. 7 can't be here, 7 can't be here, therefore this must be 7, which forces that to be the 8. Which means this can't be 8, this is 9, this is 8 by Sudoku. These are consecutive. Both of these cannot be 5 and 6, so one of these has to be 5 or 6. So if it's 6, it has to be 5 with it. If it's 5, it could be 4 or 6 with it. So one of these, so this is 5 then. So this cannot be 2 and 5. One of these is 4 or 6. One of these is 4 or 6, so 4 and 6 cannot be in the rest of the box. Therefore, we know the 2 is here, so this can't be 2, this can't be 2. Where's a 9? The 9 cannot be any of these, 9 cannot be here, so this has to be 9, which means they can't be 9. This can't be 9, none of these can be 9, therefore this must be a 9. We have a 1, 2, 3, 4 quad in column 7, so the rest of them cannot be 1, 2, 3, or 4, so this has to be 5, 6, 7. So this is 6, this can't be 2 or 3, it's 5 or 7, this can't be 6. So this is 2 or 4, which means the corresponding other cell has to be 1 and 3. So 2 and 4 over here, this cannot be 2 or 4. So this is 1, 3, and 6. Therefore, where is the 5? 5 has to be here, which means this can't be 5. So this is 3, which makes this 5. 3, 5, 8, 9 adds up to 25, correct? Yep. 8, 8 plus 9 is 25. So if this is 1, 6, this would have to be 3. So 3 cannot be in any other cell in row 1. So that can't be 3. It's 1 or 2. This is 15. That's 6. Okay, that's fine. 4 is one of those two. This is consecutive, so this can't be 4. So this is 1, 2, and 4. So we have a 1, 2, 1, 2 pair in row 1. So therefore, this cannot have, the rest of the cells cannot contain a 1 or 2. So this is 3, 4, which forces this to be the 6. So this can't be 6. This is 1 or 2. This is 1 or 2. This is 1 or 2. This can't be 3. Therefore, it must be 1 by Sudoku. Therefore, this cannot be 1 and 4. It has to be 2 and 3, which forces this to be 4 and this to be 1. And now we're just doing Sudoku. Well, maybe not. This can't be 4. Oh, this can't be 2 and 4. So this is 1, 5, which forces this to be 2, 4, which makes that 4 and that 2. So this can't be 4, so now it's a 2. This can't be 2, so now it's a 4. This can't be 2, so it's a 3. This is a 2. 8 can no longer be here. Where is the 8 in box 8? It has to be here. So this is 8. Let's see. This can't be 1, therefore it's 2. This can't be 1, 2, so it's 1. So this can't be 1, it's 2. This has to be 3 or 4, which means this cannot contain a 3 or 4, so this is 1, 2, 9. This can't be 3 or 4, this is 5 and 6. This can't be 3, so this is 4, which makes that a 3. This can't be 2. This can't be 2 or 4, so this is 1 or 3. So this is 1, 2, 3 triplet in row 4, so that eliminates 1, 2, and 3 in the rest of the row, so this is 4. 2 has to be one of these two, so it cannot be here. This can't be 3 either, so therefore this is 1. This can't be 1 or 3, so therefore it's 2. This can't be 1 or 2, so therefore it's... Wait, we have a... This is a 2. I don't know how I got that. Therefore this is 3. Therefore that makes that 1. This can't be 1. This is 2 and 3. And this can no longer be 1, so therefore it's 9. This can't be 7, so this is 5, which forces this to be 6, which forces that to be 7. This can't be 6 or 9, so this is 3. So none of these are 3. So this is a 6, 7 pair. The rest of the box cannot contain a 6 or 7, so therefore this is 9. This can't be 9. It's 1 or 2. This can't be 4, therefore now we're just doing Sudoku. This is 3, this is 4, which makes this 2, which makes this 3, which makes that 1, which makes that 2, which makes that 5, which makes that 1. This has to be 6, this is a 5. 9 can't be here, so this is a 5, this is a 9, which forces that to be 7 and 5. That's a 6 and a 7, and that's 1 and 6. And then this is 7 and 5. And that's a solve. Fairly straightforward. Just have to figure out the galaxies. Which, yeah, basically, if you're good, if you've done a lot of killer cages, it flows pretty quickly from there. I would actually consider this very easy, but that's just my personal opinion. Anyways, I hope you had an easy time on it, and I'll see you next time on Frank Puzzles. Take care.